Rated or designed values of electrical appliances. Some of the values like wattage, voltage, etc. are printed on the electrical appliances are called rated or design values. These values give the information about resistance and allowable current, etc. For example, resistance of a bulb, that is, or any device. The resistance of bulb is always calculated from the rated value of power or voltage as P equal to V square by R. So P rated equal to V square rated by R. Hence R equals to V square rated by P rated. This implies R proportional to 1 by P rated. Resistance is fixed for a given appliance which is calculated as above formula. Question. R equals to V square rated by P rated. Now find the resistance of a bulb rated 100 watt and 220 volt. Solution: we have R equal to V square rated by P rated equal to 220 into 220 by 100 equal to 484 ohm. That is the resistance of the bulb is 484. Next, allowable current or rated current. Allowable current or rated current. This is the maximum current drawn by electrical appliance for safe working. It is calculated from the rated value of voltage and power as PR, that is P rated, equal to VR into IR, V rated into I rated. Hence I rated equals to PR by VR, that is P rated by V rated. Now actual current, the actual current flowing is calculated from the supply voltage, that is IA actual current equals to PR P rated by V supplied or supply voltage. Similarly, actual power or power consumed, P actual equals to V supplied V square S, that is V supplied square by R, or V supplied square by V rated square by PR, or Vs square V supplied square by VR square, that is V rated square into PR. So actual power consumed will be Vs by VR to the whole square into PR, that is supplied voltage divided by rated voltage ka whole square into PR, that is rated power. Now let's some problem based on this above concept. For example, the coil of a heater rated as 100 watt and 220 volt is cut into two equal parts. Calculate the power consumed if one part is used at 220 volt and 110 volt. Now resistance of coil R equal to V rated square by P rated. So 220 into 220 by 100 equal to 484 ohm. So resistance of each part R dash equal to R by 2 equals to 242 ohm. Now we have to calculate the power consumed. So P equals to V supplied square by R dash given resistance, or 220 into 220 by 242, solving we get 200 watt. And in the second case, when 110 volt is supplied, so P equals to Vs square by R dash, or supplied voltage square. So 110 into 110 by R dash, solving we get 50 watt answer. The heater coil has rated value 250 volt, 500 watt. Calculate the resistance of the coil. What will be the resistance of a coil of 1000 watt to operate at same voltage? Here R is R can be calculated from the formula V rated square by PR. So 250 into 250 by 500 equals to 125 ohm. So resistance of the coil is 125 ohm. Now Now the new resistance to operate on the same voltage V square by P equals 250 into 250. Now power is 1000, so 2 will be 62.50. Next, a heater coils is to be constructed with a nichrome wire rho equal to 1 into 10 to the power minus 6 ohm meter, which can operate at 500 watt when connected to a 250 volt supply. A. What would be the resistance of the coil? B. If the cross sectional area of wire is 0.5 millimeter square, what length of the wire will be needed? C. If the radius of the each turn is 4.4 millimeter, how many turns will be there in the coils? Here, A. Rated R equal to V square by P, that is rated value of power, voltage and power. So 250 which can operate at 50 watt and 200 watt. So 250 into 200 watt, 500 watt, 125 ohm. Now we know that R equal to rho into L by A. So L equals to R into A by rho, or 125 ohm into 0.5 into 10 to the power minus 6, or 1 into 10 to the power 6 ohm meter. Solving we get equals to 62.5 meter. So length of the wire should be 62.5 meter. See, length of one turn is 2 pi r equals 2 pi r. Hence number of turns, length of wire divided by length of one turn. So 62.5 meter by 2 into pi into 4 into 10 to the power minus 3 meter, or 62.5 by 2 into pi into 4 into 10 to the power minus 3 meter equal to 62.5 into 10 to the power 3, 2 into 3.14, value of pi into 4. Or solving we get 2.4 into 10 to the power 3. So equivalent to 2.5 into 10 to the power 3, and multiplying it with 2.5 into 1000, so 2500 turns. So number of turns in the coil is 2500. Next question. A valve with rating 250 volt, 100 watt is connected to a power supply of 220 volt, situated 10 meter away, using a copper wire of area of cross section 5 millimeter square. How much power will be consumed by the connecting wires? Resistivity of copper is 1.7 10 to the power minus 8 ohm meter. Solution. Yeah, resistance of bulb equal to VR square by PR, that is V rated square by PR, P rated, or 250 into 250 by 100 equals to 625 ohm. Now resistance of wire will be equal to rho into L by A. So 1.7 10 to the power minus 8 into 20 by 5 into 10 to the power minus 6. Or 34 by 5 into 10 to the power minus 2 into 6.8 into 10 to the power minus 2 ohm, or 0.068 ohm, because the one length is 10 meters, so we need 2 wire to complete the circuit. So we have taken here 20, 0. So R wire 0.068 ohm. So R total will be 625 plus 0.068, 625.008 ohm. Hence I will be 220 by 6, 125.008. Now power consumed in the wire, I square into R wire. So 220 by 625.08 to the whole square into 0.068 equals to 0.023 watt. So we see that the power consumed in the wire is very less. So this can be neglected. Next, an electric bulb when connected across a power supply of 220 volt consumed a power of 60 watt. If the supply drops to 180 volt, what will be the power consumed? If the supply suddenly increases to 240 volt, what will be the power consumed? We have R equal to V square by V, V rated square by P rated. So 220 into 220 by 60. Now P consumed in the first case, Vs square by V supplied square by R, or 180 into 180, 220 into 220 into 60 equal to 40 watt. And in the power consumed in second case, V square by R, the 240 into 240 by 220 into 20 into 60, solving we get about 71.4 watt answer. Next question, a voltage stabilizer restricts the voltage output to 220 volt plus minus 1%. If an electric bulb rated at 220 volt 100 watt is connected to it, what will be the minimum and maximum power consumed by it? Now resistance of bulb R equals to VAR square by PR, that is rated voltage square by rated power, 220 into 220 by 100 equal to 484 ohm. So maximum supply voltage Vs max equal to 220 plus 220 to 1 by 100, or 222.2 volt. Hence P max equal to Vs max square by R, or 222.2 by 484 equals to 102.01 watt. And minimum supply voltage Vs mean equal to 220 minus 220 into 1 by 100 plus 270.8 volt. Hence P minimum equal to Vs mean square by R, 270.8 into 270.8 by 484 equal to 98.01 watt. Answer. Next, an electrical bulb marked 220 volt 100 watt will get fused if it is made to consume 150 watt or more. What voltage fluctuation will the bulb withstand? Their resistance is calculated as VR, V rated square by P rated. So 220 or 220 by 100 equal to 484 ohm. That is resistance of bulb is 484 ohm. Now maximum consumable power is given 150 watt. Now P equal to V square by R, where V is the withstanding voltage. Hence V square equals to PR, or V equal to under root PR under root 150 into 484. Solving we get 270 volt. So maximum withstanding voltage is 270 volt. So you can withstand 270 volt of supply voltage. Next, a immersion heater rated 1000 watt and 220 watt is used to heat 0.01 meter cube of water. Assuming that the power is supplied at 220 volt and 60% of the power supplied is used to heat the water, how long will it take to increase the temperature of the water from 15 degrees Celsius to 40 degrees Celsius? Resistance of the heater R equal to VR square by PR, 220 into 220 by 1000 equals to 48.4 ohm. Hence power supplied Vs square by R, 220 by 220, 48.4 ohm, or equals to 1000 watt. Power supplied used to heat the water 1000 into 60%, that is 1000 into 60 by 100, or 600 watt. The heat developed in time T equal to Pt or 600 into T or H equal to 600 T. This is equation 1. Now heat needed to raise the temperature of water from 15 degrees Celsius to 40 degrees Celsius, dq equal to mw sw dt, or q equal to mw sw into T, where T is the temperature difference, and mass of water will be rho water into V sw into T, equation 2. Hence from 1 and 2, 600 T equal to rho w V into SWT, hence T equal to rho w V SWT by 600, and using all value we get about 29.1 minute answer. An electric kettle used to prepare tea takes 2 minutes to boil 4 cups of water. 1 cup contains 2000 cc of water. If the room temperature is 25 degrees Celsius, if the cost of the power consumption is raised 1 per unit, 1 unit equal to 1000 watt hours, if the cost of power consumption is raised 1 per unit or 1 unit 1000 watt hour, calculate the cost of the boiling 4 cups of water. B. What will be the corresponding cost if the room temperature drops to 5 degrees Celsius? Here mass in cup of water, rho w into V, 10 to the power 3 into 200 10 to the power minus 6, or 2 into 10 to the power minus 1 kg, 0.2 kg, and mass of 4 of water, 4 into 0.2, 0.8 kg. Next, heat is given by kettle to boil water, H equal to ms delta T or 0.8. Specific heat of water is 4200 joule, so 4200 joule at temperature 100 minus 25, 0.8 into 4200 into 70.5 equals to 252 into 10 to the power 3 joule. Time taken in boiling 2 minutes, so 2 into 60, 120 seconds. Hence power consumed P equal to H by T, 252 into 10 to the power 3, 120 watt, or equivalent to 21 into 10 to the power 2 watt. Now number of unit consumed, so 252 into 10 to the power 3 joule by 3.6 into 10 to the power 6 joule equal to 7 into 10 to the power minus 2 unit. So total cost unit into rupees, 7 into 10 to the power minus 2 rupees, or 7 10 to the power minus 2 into 100 paisa equal to 7 paisa. B. H equal to 0.8 into 4200 into 100 minus 5, or 0.8 into 4200 into 95 equals to 3192 into 10 to the power 2 joule. Number of unit 3192 into 10 to the power 2 joule by 3.6 into 10 to the power 6 equals to 88.66 10 to the power minus 3. इसलिए कॉस्ट 88.66 into 10 to the power minus 3 rupees, 88.66 into 10 to the power minus 3 into 100 पैसा, और 88.66 into 10 to the power minus 1 पैसा, और 8.866 पैसा इक्विवेलेंट टू 9 पैसा अबाउट.